Please welcome Dr. Steve Palumbi.
Thank you very much, and thanks for coming out on this Thursday night. I'm not going to talk very much about population genetics and the genomics and all that we do. That comes later tomorrow. Instead, I'm going to try to talk about something that I think is pretty common in our experience these days. It's a word that we see all the time. And it's a word that we encounter in all kinds of new places, like when you're buying a light bulb, or when you're buying a car, or when you're choosing your coffee. You come in and hit this word, sustainable. And what I wanted to do tonight is to talk about what we mean by that and try to give you a glimpse of actually a really good news environmental story, something that actually has gotten better. Because sometimes I think we look out into the world and we see things that are getting worse and worse and worse, and we would like to know that there is actually a way to make things better, and there is. In order to do that, what I want to do is talk about this word and ask a little bit about what it means, and show you a different sort of concept of it that we've actually encapsulated in a different sort of science communication product. Sustainability, if you're an ecologist, sustainability means that an ecosystem is able to keep living and producing and doing what it does more or less in perpetuity. And that means the ecosystem has productivity that sustains it, and it's also subject to disturbance that is often a natural part of it, always a natural part of it. And the balance of sustainability is this balance between productivity and disturbance. We add to disturbance in a lot of ecosystems, and we can throw this off balance. There's other things like resilience and diversity that help with that as well. All of these things seem very scientific maybe and just kind of mumbo-jumbo. What we've tried to do is take these concepts and build them into a different way of communicating science. It's something that we call the short attention span science theater. And this is built around the concept that the normal human attention span right now is about the length of a pop song, 3 minutes and 15 seconds. And what we've done with this is to build an interactive website with micro-documentaries, 3 minutes long, about the concept of sustainability, what it means. We've used coral reef examples in this because I can get the film company that does these to go to a coral reef for free. And we have built the idea of the sustainable world around the reefs and this concept of micro-documentaries. To give you an idea of what they're like, I'm not going to actually take you to the site for long, but the site is microdocs.stanford.edu. If you can pull it up on your browser, it looks like this, and it gives you access to these 35 micro-documentaries in any kind of interactive way you want. If you want, I'm taking a great risk here and actually running this site. But if you want to know what the elements of sustainability are like, though, for example, you can click on that tab. That'll take you to this. It'll show you the different kinds of micro-documentaries we have about what sustainability means. This is the overview. This is the one about productivity. And every one of these can play off your laptop or off your desktop just by hitting those buttons. It also has a set of information pages that explains in a little greater detail what productivity means, and in this case, and gives you hot links to other parts of the web, so you can drill down a little bit into that. What the idea here is to give access to people 24/7 and any internet cafe anywhere in the world to the ideas that we as scientists always talk to one another about. When I talk to one of my colleagues about sustainability, they know exactly what I mean. But when I talk to somebody at a bus stop about sustainability, they don't. And that divide is what really makes it difficult for science and society to get in groove, and for us to do the job that we have to do as scientists, and for society to improve the way it can. The site is built as a prototype, and what I hope you can do is, if you want, go check it out. Explore some of the videos. It's been up for a month. It's got 250,000 hits so far, so I think it's something that people have been able to use and have been enjoying. Instead of going through in nauseating detail all those 35 micro-documentaries, making short attention span sort of drag out way too long, what I thought I would do is give you a different sort of story here, a different sort of sustainability story that talks about how one part of the world, the part that I live in, Monterey Bay, was actually knocked way off its sustainability balance and then came back to life. Because the ability of an ecosystem to come back to life is really critically important. If people have been to Monterey, it's one of the most gorgeous places there is. Stunningly beautiful along its coastline. The kelp forests are alive. The wildlife is great. And the question is, why is it so beautiful there? Has it always been that way? Did the vagaries and the environmental problems of the last 50 years just pass this little bay by? And the answer is no. 80 years ago, it was pretty much an industrial hellhole. And it was hit by all the same problems that we see in environments all over the world, marine and terrestrial. But it came back. And so the question is, how did it come back? What happened to allow that to occur? This is actually a subject of a book that I've just finished writing with co-author Carolyn Satka, who's in South Carolina. And it's a chronicle of the demise of Monterey Bay and the kind of wacky personalities in Monterey that helped turn it around, and the sorts of things right now that have kept it in place and have allowed it to not only improve but stay improved. So when the recession is over, the book will be available for sale, I'm sure. Until then, it's all going to be micro-documentaries, I'm sure. Monterey's a little bit north of here. It's a little bite taken out of the coast, about 100 miles south of San Francisco. And before Westerners hit these shores, it was the home of a very varied Native American cultures. The Rumsens and the Ohlone lived around Monterey Bay, especially right here. This is the Monterey Peninsula, where I'm going to spend most of my time talking about. They lived here for centuries, thousands of years, and kitchen middens and archaeological remains tell us that they used the marine environment to great extent. Not necessarily always sustainably. Things came and went in those middens, but they were here for thousands of years. Like in most places that we've talked about as ecologists, Western powers came in and looked at the environment in a very different way. Jean de la Perouse sailed into Monterey Bay in 1786. There was a mission there already, and he was puzzled that the Spanish mission wasn't doing more to exploit the natural riches of the area. He wrote back to the King of France, "There's not a country in the world which more abounds in fish and game of every description." Monterey Bay. In fact, he complained that He complained not only were there so many whales in Monterey Bay, but their breath, by blowing around the ship, was so incredibly dense that it made an annoying stench that he found quite repulsive. And this is a fellow who had sailed around the world in a boat of unwashed Frenchmen, and he still found that annoying. And in addition, there were lots of well, it's supposed to say sea otters, actually, but it's sort of an interesting lapse. There's lots of sea everything in Monterey. And he actually wrote to the King of France and said, the Spanish don't seem to know what they've got in these otters. These sea otters are really valuable in the market in China, and he didn't understand why the Spanish weren't going after them like wild. Well, in fact, they did. And over the next 50 years, sea otters became the first exploited species on the west coast of the United States, the first extirpated species on the west coast of the United States. And it set a whole series of things in play that changed the ecology of the west coast of the United States. It also began a precedent in which something that was valuable was considered a commodity. It was taken in excess, and after it was all gone, then people moved to something else. The number of otters taken out of the area is just amazing. About 100,000 otters taken from about San Francisco down to Baja, shipped to China where they fetched about $30 a piece. Just by contrast, at this time, a house in San Diego cost $90. What happens when you take the otters out of an area? Well, they didn't know this at the time, but now we know that otters play a huge role in the ecology of coastal kelp forests, because one of the most sought-after food items for otters, sea otters eat nothing but seafood. They have to eat a third of their body weight a day in order to maintain their temperature. So 25 pounds of seafood goes into that animal every day, and what they really like are sea urchins and abalone. Well, those two species are very, very strong herbivores. They chew down kelp if they have the chance. This is a bunch of sea otters ganging up on the kelp plant there. And without the otters keeping these herbivores in check, that meant that the herbivore population bloomed. Probably no one was there to actually observe it. And that the kelp forests probably were decimated and destroyed. If we look at aerial photographs of the California coast about a century later, in the early 1900s, you see wisps of kelp forest, but not the thick things that we have now. So otters were taken out because of their pelts. They created an ecological cascade that changed the kelp forest ecology all up and down the west coast for centuries after that. I didn't stop there. This is sort of the demise of Monterey Bay, because one after another species were spied as being economically valuable and taken. A whale, a humpback whale or a gray whale, was worth between 1 and 2 pounds of gold in 1850. Because of that, there were shore-based whaling operations set up all along the west coast of the United States, and the Hawaiian whaling fleet, when it was at berth for the winter in Hawaii, would sail over to the lagoons in Baja, Mexico, and take gray whales there. Gray whales were decimated over a period of about 35 years. They went from being so abundant that Charles Scammon wrote about them as rolling around in the surf in Monterey Bay to being virtually extirpated and thought at some points to be extinct. Seals followed because when there were no more whales, and seals and sea lions were thrown into the vats and boiled for oil. The next sort of thing that happened in Monterey was that the abalone, which were so abundant because the otters were gone, then became a target themselves. Chinese community blew onto the shores of the west coast of the United States in 7 junks that left Guangdong in 1853. And one of those junks made it to the west coast, and they started this small Chinatown in Monterey that lasted from about 1855 to 1906. It eventually grew to be a center of about 400 people working, taking abalone. When the abalone were gone, they started taking squid. This was acres of drying squid on China Point, the point that the Marine Station is on right now. And the activities of this particular community changed, again, the way the coastal kelp forest proceeded. All of this is going on very quickly. I'm trying not to dwell on it, but what we get to is another set of exploitations that eventually brings us to the industrial age. About at the same time as all of the Chinatown is beginning its demise, the very first canneries were started in Monterey. And this is what people mostly know about the history of Monterey, Cannery Row. Well, Cannery Row is actually this little road there. It was the main cannery road in the 60s. This is the biggest cannery in the world at the time, the Hopkins Cannery. And this is a little bit of the Hopkins Marine Station here. And this was where Chinatown was just a couple of decades before this. In this particular part of the history of Monterey, there was the beginning of a real pushback. And this is where we start to see a little bit of a change. Up until this point, it was just normal to take everything you could, try to make money on it, and then go away. This woman, Julia Platt, was one of the first voices that said, maybe this isn't the right thing to do. Julia was an amazing woman. She had a PhD in zoology. She had to get that PhD in Germany because you couldn't get a PhD in zoology in the United States if you were a woman in 1890. And she came to Pacific Grove, a little town next to Monterey, and began working as a civic activist to try to bring a perspective about the marine life of the bay to the way this little town was running. She was actually quite a rabble-rouser. She had an idea that she thought was the right one. She just went for it. This was a famous in Pacific Grove anyway, incident of Julia knocking down a fence. The story was that a particular owner of a waterfront property had built a fence across the beach. That's against the law in California. Actually, it's against the California Constitution. Julia tried to get the fence down. She went to the city council. She went to the police. No one would help. She knocked the lock off. They put it back. She filed it off. They put it back. And then this is her with a crowbar taking down the fence and hopefully keeping it down. But she didn't just do that. She put up this amazing sign. It says, "Opened by Julia B. Platt, this entrance to the beach must be left open at all hours when the public might reasonably wish to pass through. I act in the matter because the council and police department of Pacific Grove are men and possibly somewhat timid." So that gives you an idea what Julia was like. And it worked, because the fence stayed down, the police department and the city council were a little bit chagrined, and access to the beach, which Julia thought was really an important part of the culture of Pacific Grove and Monterey, was guaranteed. But next door, while she was knocking down fences, the sardine nets were actually going big guns. Sardines were becoming a very, very big business in Monterey, and Cannery Row was defined not just by one cannery, but 29 canneries in a row that together made up the biggest industrialized fishing center in the country. And it increased dramatically from about 1917 on for a number of different reasons. One is that there were a lot of sardines, and also because there was a shift in the ability of the canneries to not only put sardines in cans, but also put sardines into fish meal and fish oil. It turns out that canning is not a profitable business. That fish meal and fish oil were profitable businesses in California because there was an inexhaustible market for fertilizer. So when the state legislature started letting the canneries put more sardines into fish meal and fish oil, then the actual take of sardines went up, and the capacity of the canning industry increased dramatically. This was a huge amount of sardines being taken out there. Well, what did Julia do about this? She worked and worked and worked trying to get the canneries to either stop polluting the air, polluting the water, or curtail their activities, and she was getting nowhere. Why? Because it was the biggest employer in Monterey and Pacific Grove. The canneries had the legislature in their pocket, the Fish and Game Commission in their pocket. Julia couldn't do anything to stop the canneries, and so what she did what she could do in her own town. What she did was to go to the city council of Monterey and try to get them to set aside a part of the shoreline as a special marine protected area. The city council said, if you want to run the town, why don't you be mayor? So she ran for mayor. She was elected mayor, and immediately got the city council to pass an ordinance that set aside all of the shoreline of Pacific Grove as the marine gardens, and the part of the shoreline in front of what is now the Hopkins Marine Station as a fully protected refuge. Well, it turns out that the Pacific Grove did not have the authority to do that. The state owns submerged lands, and so she had to go to the state legislature and get them to pass a bill, and the governor to sign it, which ceded the right to control the subtidal lands from the state to the town of Pacific Grove. They had never done anything like that. They had never did anything like that again. But as a consequence, she was able to set up the first fully protected marine area in Central California. And she did it for reasons which, from the standpoint of modern science, are remarkably accurate and completely in tune with the same kinds of process that's going on now with the California Marine Life Protection Act and the designation of marine protected areas all along the coast. She said that she wanted to set aside this area so that it could thrive, and from which the tiny larvae may swim or be carried by currents to all points along the shore and become attached, grow up, and replace those taken from food for food or curio. Well, that's exactly the sort of thing that modern conservation and fisheries practices would suggest, that setting aside areas of protected shore allows for those native marine ecosystems to thrive. And in 1931, Julie was the only person who was thinking that way, and was the only person with enough personal clout to make it happen. So she set up the Marine Wildlife Refuge here. This is the peninsula of land that Hopkins Marine Station is on. This is China Point. This is where the Chinese village was. And this is right now the Monterey Bay Aquarium, but it used to be the Hopkins Cannery, the biggest one. And that's the refuge as Julie designed it in 1931. And it was expanded in 1984. And then in the latest version of the Marine Life Protection Act in Central California, this refuge has been extended about a mile to our left here to another point called Lover's Point. But in 1931, it was the only game in town. It was the only thing protected in the whole area. Next door, Cannery Row was in the middle of its heyday. If any of you read John Steinbeck's book, The Cannery Row, this was the period of time that book was written about. It was a period of enormous economic activity. And it was the period where more sardines were landed here than anywhere else in the world. It's hard to tell how many tons per year that means, but if you boil it down to pounds per day, it's 1 million pounds of fish per day were brought into Monterey and processed. Well, canneries are not particularly clean industries. They spew all kinds of foul odors into the air, particularly by the reduction process. And they also put a lot back into the water. The canneries, for example, had wooden floors where the boards didn't meet. There was a gap between every board in the wooden floor, and they were all built out over the water. And the reason was so that the slop from the canneries could get washed down and then just fall into the water underneath. A modern cannery loses about 10% of the volume of what it's processing back into the water just by loss. And if you apply that to these canneries, and it was probably more, that's about 100,000 pounds of fish guts and scales and other stuff that falls into the water every single day. That's more than the raw sewage that Monterey would have put out during that period of time. And it undoubtedly had a huge impact on the quality and the pollution levels of the shore. Rolf Bolin was a researcher at the Marine Station in the 1940s, and he says the fumes from the scum floating on the waters of the inlet of the bay were so bad that they turned lead-based paints black. Other people have said that the entire shoreline was coated by pallid sea anemones that basically spent their lives catching the fish guts off the sardine, the canneries, and then using those for food. So at this particular time, it was basically the worst time in Monterey Bay. The air was really not all that easy to breathe. The water was fairly foul inside it. And the sardine business was booming. In fact, there's this little doggerel sort of children's rhyme. The Carmel by the Sea and Pacific Grove by the Lord were sort of little things that you could use to tell where you were on the Monterey Peninsula, and then you could also tell you were in Monterey by the smell. Well, the sardine business actually didn't last. Many of you probably know that the sardine business collapsed right after World War II. In fact, part of what happened during World War II was sardines were actually going into the cans by then because they were part of the war effort, and anything it took to get sardines in cans, to get those cans out to GIs around the world was going to be okay. The last of the sardine balls in Monterey Bay were scooped up by the fishing fleet that was directed by Navy spotter planes that were circling around the bay, radioing back where those sardines were. And so the sardine population began to collapse because of overfishing. But there was something that went on as well. And this change in the environment actually made a big difference to how well the sardine industry could recover from this loss. Turns out that not only did fishing cause sardine populations to change, but the oceans also caused the sardine populations to change. In the Pacific Ocean, there's a climate cycle called the Pacific decadal oscillation. It moves back and forth about every 20, 30, 50 years or so. And it basically has two phases. A positive phase where the waters along the west coast of the United States are relatively warm, and a negative phase where the waters along the west coast of the United States are relatively cool. And historic records plus archaeological records plus paleontological records tell us that the PDO has shifted back and forth, not too regularly, but about every 50 years or so for a long time. Over the last century, this is the record of the Pacific decadal oscillation. And you can see sometimes it's quite positive and sometimes it's quite negative. But look at this time right around 1940. Around 1945 is the period where the Pacific decadal oscillation went from its highest point known to one of its lowest point knowns. It's the strongest change in the Pacific decadal oscillation ever seen. And it's associated, this particular change, with that graph of sardine catches that I showed you. That's the graph of sardine catches. And just as the sardines are being overfished because of the war effort, the ocean climate was changing. And because the ocean climate was changing, it was changing from warm water, which favors sardines, to cold water, which favors anchovies, and not sardines so much. So as a consequence, when that overfishing happened, leaving very few sardines left in the water, it was just at the period of time where ocean conditions wouldn't allow the sardine populations to grow back very much. What usually happens in a sardine industry, it's not that sardine populations had never crashed before. Usually what had happened and what everyone expected was that they would crash, it would be a few years, then they would come back again. And the industry could survive a few years of bad sardine fishing. In fact, the sardines crashed. They came up a little bit in about 1950. Everyone thought it was going to be okay. And then they crashed, and they stayed crashed for about 20 years. The sardine canneries themselves went bankrupt. They sold their equipment to South America, shipped everything down there, and started fishing anchovetas down in South America. Cannery Row turned into a ghost town. The canneries, one by one, burst into flames. And were destroyed, and it left the entire town without an economic base and with an industry that couldn't survive and without anything to replace it. Economically, it was a very bad time. But in terms of the ecosystem, it actually was the time where things began to clean back up. The water became cleaner over decades, the air became cleaner, and things began to get better because of this economic demise. Well, that wouldn't have been enough to bring Monterey Bay back to life, but at the same time the canneries were booming, something else had gone on along the Big Sur coast. Oops. That's what the Hobden Cannery looked like in 1970 after it had closed. This is the Bixby Bridge. It spans a big gorge between on the Big Sur coast. We're looking at it from the north. Big Sur, the Point Big Sur is to the south here. And it used to be, before 1936, that road went inland right there and left a big bite out of the coast that nobody got to. In 1936, because of the Depression, there was a lot of labor, there was infrastructure projects going on, and a series of bridges were built along the Big Sur coast, including the Bixby Bridge, that opened up this coast to traffic. And it turns out, along this coast, somewhere in among those rocks there in 1936, someone discovered the southern sea otter again. It hadn't been seen for decades. It was thought to be extinct. But in fact, a small raft of about 50 or 100 individuals was living along the Big Sur coast here, well away from where the road was. They were discovered in 1936, protected by the U.S. Fish and Wildlife Service, and slowly, over the intervening years, as the sardines came and went, as the water became slowly better in Monterey, they worked their way up the coast towards Monterey Bay from the south. Well, in April 1963, they re-entered Monterey Bay. We know when they came in because it was very big news. When they came around Point Pinos into Monterey Bay, everyone came, lined the roads with cars and sat and tried to get a glimpse of these amazing animals. They didn't stay around the Point Pinos in Monterey Bay that long. Instead, they made a beeline for the Hopkins shore. And the reason they made a beeline for it was because everywhere else in Monterey, it was sort of a normal environment there, lots of sea urchins. But people had been picking the abalone off those shores for a very long time, down to about 20 or 30 feet or so. Skin divers in their underwear, this is before wetsuits were invented, could go and pick up abalone. The only place where you could find abalone in abundance in the intertidal in Monterey was at Hopkins. And there, reports there say that essentially the shoreline was covered with heaving abalone all over it. It was because Julia had set up the marine refuge that meant that people couldn't collect abalone there. The otters came right back to the Hopkins shore. They've been there ever since, and because they were there ever since, they transformed the Hopkins and the China Point shoreline into something that hadn't been seen there for about 170 years. This is a map drawn in 1972 by John Pierce and one of his grad students, Richard Lowry, of the kelp forest that had grown up around the Hopkins Marine Station. All of that kelp forest there wasn't there a decade before the otters were. But the otters arriving back in Monterey meant that the abalone were eaten, the sea urchins were eaten, the kelp forest regenerated, and they regenerated not only here, but it regenerated all up and down the Monterey Peninsula. This is a distribution from the Monterey National Marine Sanctuary showing the distribution of kelp forests in the 1980s. Essentially, kelp forests are thick and abundant all along this coastline as they would naturally be. The kelp forests brought back with them a whole range of species that live in kelp forests. A huge number of different fish and invertebrate species live more abundantly there than elsewhere, and so the rebirth of the kelp forest led to the rebirth of these species as well. Some of them are amazing little creatures like that you can see otherwise. Some of them are typical rockfish, greenling, halibut that people like to fish for. Because they're fish, it meant the seals could come back. The seals were also protected by the Marine Mammal Protection Act, and the consequence of the cascade of otters to kelp forests to fish to seals meant that they had a food supply, and they began returning to the Hopkins shore starting in the 1970s. Right now, the Hopkins West Beach is the biggest haul out for harbor seals along the west coast of the United States. The seabirds also came back. I didn't talk too much about seabirds, but they were pretty much wiped out in Chinatown first, and then their recovery after that was delayed quite a bit after World War II by the introduction of DDT. Banning of DDT in the 1960s meant that brown pelicans, cormorants, and egrets began to come back in great numbers, and then the Marine Mammal Protection Act brought back the whales. The humpback whale, but also gray whale abundances have been increasing over the last couple of decades. They're nowhere near as abundant as they used to be when Scammon talked about them rolling around in the bay. But now, on a good day on a whale watching cruise in Monterey, you can actually see humpback whales, gray whales, killer whales, and blue whales. So you couldn't do that anywhere in this country 40 years ago. So far, things have been rebuilding pretty well. The ecosystem is coming back. Fish abundances are going up. And at this stage, this is when in most recoveries, a fishing town like Monterey would begin to think, well, great, let's eat it again. Let's build our fishing fleets back up. Let's go back and get out of that environment the things that we know how to get. And that usually, in this sort of situation, results in another series of overfishing and collapses, and you get into a cycle. But what happened in Monterey was a little bit different than that, because a set of people at the time in the 1970s got a very kind of wacky idea. Their wacky idea was that wouldn't it be interesting if instead of eating the ecosystem, we tried to show it to people? Maybe it would be fun to set up an aquarium that had local species, and that aquarium could thrive off of the healthy marine environment of Monterey, and people would be entertained by it, and they would be amused and thrilled by it, and they might actually be educated by it. Those people included Steve Webster and Chuck Baxter, Nancy Burnett, and Julie Packard. Nancy Burnett and Julie Packard are daughters of David Packard, and because of the connection with the early Packard Foundation, they were able to build the Monterey Bay Aquarium. It was thought at the time to be kind of a rich man's fancy. No one had ever done anything like that. They thought maybe it would attract 300,000 people, maybe it would break even in 20 or 30 years. It was a nice project, family kind of project. This is Julie on the beach of Hopkins with the Hopkins cannery in the background and the model of the Monterey Bay Aquarium inside. In fact, the aquarium has been an enormous success. It opened to 2 million visitors the first year, and it has been a linchpin not only of marine education in Monterey, but also it's been a foundation of the regeneration of the tourist industry there. For the first time, the town's economy began to revolve not around exploiting marine resources, but also, there's still a fishing community there, but also using marine resources to amuse, educate, and frankly attract business. So that was a huge difference in how Monterey began to look at its marine resources. Early on, just as something to take. Now it's something to nurture because having the stuff in the water is just as valuable as taking it out and selling it. Well, today Monterey is a nexus of a lot of different industries. There's still fishing. Squid is the most lucrative fishery in Monterey. In fact, it's the most lucrative fishery in the entire state of California. Tourism is the biggest industry in Monterey County, second only by agriculture. Wildlife viewing is a bigger business than wildlife processing. Salmon boats have been converted to whale watching boats. This is a little boat that goes back and forth in front of the marine station looking at us, I suppose. And there's a large number of teaching and research institutes around the Bay that bring students in from all different levels. We have elementary school students, high school students, college students, researchers. The Hopkins Marine Station is there. The California State System has a marine lab there. Santa Cruz has a marine lab. Monterey Bay Aquarium has a marine lab. And so this confluence of educational research also generates a lot of interest and enthusiasm. Well, what it leads us to is it leads us to a situation where there's a balance. We have all of these things going on at the same time. And it suggests a couple of general lessons about why this has worked in Monterey that could be perhaps applied to other places around the country and around the world. Why is this stable? Why does it work? Well, one of the things that I think that we can take away from this is to realize that although scientists like to talk about the importance of biological diversity, in fact, what's really important here as well is simple human economic diversity. The biggest problems in Monterey Bay in terms of its wildlife have occurred when one major industry has had all of the economic and political clout. When the canneries were booming, nobody could say no to them. They got whatever they wanted from the legislature, from the California Fish and Game Commission. When there's a balance among different sorts of industries, fishing, tourism, education, retirees, then in fact that economic diversity allows different sectors to have their way at different times, and you don't get the massive overexploitation of the marine environment that we did in the past because these different sectors don't agree about what should be done, and so as a consequence things don't get too far out of whack. That kind of human economic diversity, I think, plays a very similar role to biological diversity in maintaining stability and resilience in that kind of system. I don't know this for an absolute scientific fact. It just seems like at least a hypothesis we can advance about how Monterey managed to get this way. It also suggests something really kind of interesting and counterintuitive, that in a consequence of that kind of diversity is that people argue. and that we're often, especially if you're a scientist involved in conservation policy issues, you tend to think of arguments as being bad. You don't want arguments. You like everything to be kind of smooth. But those arguments mean that two things are happening. One, there's something to argue about. There's some resource there. There's something there worth saving. And then two, that no one player has got so much power that they have a say, the ultimate and complete absolute say. It means that there is a balance of opinion. It means that there's a way of interacting that leads to some sort of negotiated resolution. And so a little bit of conflict is a natural way for these kind of resource decisions to be made. So I've been thinking about this particularly in terms of the Marine Life Protection Act in California. Over the last couple of years, California has led the nation in setting up a series of marine protected areas along the coast. They have not been without controversy. It means that there's been a lot of fights about them. And at first that seemed like that was a system that wasn't working well. But in fact, those interactions and those negotiations among different stakeholder groups have led to systems that are more stable, systems of marine protected areas that are more stable, more in concert with what the community thinks, and in fact are systems that are likely to be actually able to be preserved for a long period of time. Now, Southern California is facing the arrival of the Marine Life Protection Act. It has been focused on Central California for the last couple of sections, but now the process of setting aside some areas along the Southern California coast as marine protected areas is coming to your town. You can expect over the next couple of years some debate about that. You can expect some controversy about that, and you can expect a resolution about that because the process has been working out. What I want to do in this sort of example is just to say, get involved in that. But don't get involved in it and expect it to be without conflict. Get involved in it because you have a point of view, and get involved in it because you have something to say about it. By getting involved in it and participating in it, you'll be part of that process, the democracy, if you will, of natural resource use in this case, and you'll see how the system works, and you'll see what can be done with it. At the end of the game in Monterey, the success there depended upon a couple of really pioneering people, Julia and a marine refuge, which sparked a change that she couldn't see coming and could never have predicted. And it didn't come within her lifetime. She died in 1934. And the real value of her refuge really wasn't seen until 1963 when the otters discovered it. That didn't mean that it sat useless for 30 years. It just was biding its time. Likewise, I think when we look at what we're doing now in our society, what we can do, we shouldn't think about what it's going to do in a year or two. We should think about what we ought to do, what we think is right, and we should do it now, even if it takes 30 years or so to pay off. Thanks a lot. So Susan says that I could take questions if you wanted. If there are any. Yeah, Phil.
I like your comment about the fact that discussions can be good, but I think there's an aspect of how they're good that you didn't mention, and that is that when people discuss things, they sometimes listen to each other. And as soon as they start listening to each other, you get the democratic process going. I think that always leads to a better outcome.
I completely agree. And one of the amazing things about the Marine Life Protection Act process, as it's been jiggled into shape, is that it does result in actual discussion. And from a scientist's point of view, it's the best kind of discussion because the science is there to help the process along. We're there to help people understand what the consequences of one kind of marine protected area design is or another. But the science is not in charge. It's the stakeholders and the community people that are in charge. And I think that's another reason why this particular thing has been working so well. Yes, sir.
What do you anticipate will be the effect on Monterey Bay of the climate change? what sort of time period do you anticipate changes to be substantial and occur? And tell us a little more, if you would, about Hopkins and how it is involved, not simply in teaching and research, but also in, I imagine, some degree of political activism.
The question is, what do we expect climate change to do in Monterey? What kind of time frame is that going to occur? And what is the Hopkins Marine Station a hotbed of political activism? The first two, actually, I'm talking about tomorrow at the symposium. But the basic point is that we have already seen global climate change affecting Monterey Bay. Over the last 30 years, we've seen the increase in species which normally are more abundant down here in the south than they are up in Monterey in the central coast. A large set of species have become much more abundant there. They are usually southern. We've seen then a shift of species from the south to the north. We've seen changes in plankton. We've seen changes in growth rates. How fast is that going to go to some sort of completion? I frankly do not know. But if you look at the projections over the next 90 years, by 2100, ocean temperature will be very different than it is, and the acidity of the ocean will be very different than it is. And that will have dramatic changes in Monterey. I don't know what they'll be exactly, but my guess is that will push those ecosystems beyond what they can normally resiliently stand. And again, that's sort of for actually the colloquium here over the next couple of days is about those issues. And I think many speakers here are going to talk about exactly those kinds of things. Not for Monterey Bay, I'm the ocean, but for other habitats as well. In terms of political activism, Hopkins is a part of Stanford University. We're all professors. What we consider political activism is pretty minor. What we try to do at Hopkins is to generate information, provide it to policymakers, and to come up with answers to complicated scientific questions whenever we can. There's always a debate in conservation biology about when you're being an activist or when you're being an objective scientist, and different people have basically live on different parts of that spectrum. Me personally, I live on the part of the spectrum that says if I was a physician and I knew because of the science that a drug was going to poison you, you'd want me to tell you. And so I regard the planet as a body and the kinds of things we do to it as potentially poisonous. And so I think it's my job to tell people, in my scientific judgment, the planet's being poisoned or ruined, and I need to tell them that. But I also need to tell them why I say that. And I think that's what scientific objectivity is, where you provide both sides of the story. You say, my judgment is we're in big trouble.
Do you... I think that Pacific Grove Marine Gardens and the glass bottom boats were a better picture of that marine life reserve than the aquarium is. I understand the difference between the number of people that can be handled. I could only go 16 people at a time because of the marine gardens. But do you think that Julie Packard will become, because men are timid, will Julie Packard become the replica of my great-grandmother's plaque?
Was she your great-grandmother?
Yeah.
Excellent. Good talk. No, I don't think so. Julia, for all that she did and all that she was able to accomplish was pretty much she was out there solo. What she managed to accomplish, she did by herself, and when she died, the only things that survived her were the things that she wrote into law. She was not good at consensus building. She was not good at building organizations and building a new way of life. She was good at being right in her mind and then forcing it down people's throats. And when she was right about it and she did that, then it worked out really well. There's a couple of other things she did in Pacific Grove that weren't all that great. But we can talk about that later.
Because you can't drink there.
Well, you couldn't at the time.
Do something? Don't you think Julie Packard could do something?
Well, I think Julie and the aquarium in general, in a different way of going about it, is actually building coalitions, finding partners, finding a different constituency, and then building that and making that at least as powerful as other constituencies. You know, I'd say that's what the aquarium partly has done, is build not just a couple of people interested in the life of the sea there, but build a whole set of people that have enough numbers and enough power and enough economic incentive to be a balance against the other forces there. I started off talking about sustainability and a balance, and part of the balance in an ecosystem is productivity and disturbance. We have this other balance in human affairs of points of view. So I'd say Julia was great at certain things, but she couldn't get a constituency behind her about a lot of things. For example, she thought men should not be on the beach topless. She just thought that was repulsive. And she tried to put a law in that said that men couldn't be on the beach topless, and it didn't work. So, but if you have other stories about her, I think that would be great.
I have lots of stories.
Oh, excellent.
You're talking about Julia Platt, but I'm asking you it's about Julia Packard.
Mm-hmm. And I'm saying what
you could do to move this thing forward, because I'm too old to see it get solved in my lifetime. And I think it needs to get solved now.
What I'm saying about that is that Julie Packard and then Nancy and the other people who built the aquarium have built a constituency that'll outlive them. And they don't need the law. They don't need to change. They don't need to get something written into the state by the state legislature and do one thing. They have built a way of life. They have built a way of looking at things, I think, that has a legacy to it. And that's a different way of going about it. Yeah.
That was a great talk, because it sort of gives you hope. Some of our colleagues talk about, one of them particularly gets a talk called The Rise of Slime, which is about the evolution of dead zones in marine areas. Is that an heretical path? Is there something about Monterey Bay that at the upland that enables it to regenerate rapidly, given when you take away the flipping process that can come back?
Well, the rise of slime, you know, my mentor Jeremy Jackson's phrase, comes from a lot of different things, but mostly simply over-fertilizing the ocean and leading to a huge shift in the way the ocean is operating. That can change if you stop over-fertilizing the ocean. The Black Sea, for example, used to be one of the most damaged big bodies of water on the planet because of all of the extra fertilizer flowing into it from the Soviet Union. That was curtailed after the breakup of the Soviet Union, and the Black Sea substantially shifted in the way that it was working as an ecosystem. So it's possible for even big changes to be shifted by that. We have seen, however, that global climate change may be shifting the way upwelling works. Upwelling is cold water near the coast coming up to the surface, fertilizing the coast. That's what makes the west coast of the U.S. here a little colder than it should be and a lot more productive. And the way that happens can be changed by shifts in temperature and global climate change. So in Oregon and Washington, for example, there are areas of virtual dead zones that are not caused by over-fertilization, but they're caused probably by shifts in currents because of global climate change. I don't think that we can do anything about that without changing the way we dump CO2 in the atmosphere. At one level, the CO2 problem is the biggest problem. It's like the human population problem has always been. It is the big problem. And until you come to grips with the CO2 problem, we're going to have things like that we can't do anything about. So I agree. I mean, the reason why I like this story is because it is a story of hope that a local community in a small place can actually do something that makes a difference. But there are big issues that it can't solve. What do you do then? Do you despair and learn how to eat jellyfish? That's probably one way to go about it. But the other way of thinking about it is that if we're stressing the planet with global climate change, than the ecosystems that are going to survive that until we fix the CO2 problem. The ecosystems that can survive that are the ecosystems that are the healthiest ones, that are not being stressed in every other way by sewage and sedimentation and development and overfishing. And so by changing those things we have a handle on, we might be able to slow the negative effects of global climate change. Yeah.
Is the idea of sustainability making strong inroads into political thinking?
The question is sustainability making strong inroads into political thinking? This week in Illinois, I think it is. but not last week. I believe the concept of sustainability is becoming something that you can talk about in Washington. I was just there a few days ago. There's just an enormous feeling of hope there that the serious problems our country and our world are facing right now might be solvable by smart people, from all walks of life and all political persuasions, hunkering down and working at them. And I think that's a really good thing. The other thing is that people may be thinking a little bit more than just the next election cycle, which I also think is a good thing. Whether that's sustainable or not, I don't know. Questions up there? Yeah.
You brought up sea otters before.
I'm sorry?
You brought up sea otters before, and how they were key to the changes up there. We have a law in California now for permitting sea otters to enter our California body. Do you think there's any hope our system can come back any sort of sustainability as long as we keep a major apex predator like that in the southern part of the state?
Well, sea otters can't read. They don't know there's a law against it. Right now, to be honest, there was a period of time when the sea otter population was expanding in numbers and expanding in range. And at that point, there was a very serious debate about whether the sea otter population should be allowed to expand south of Point Conception into the California Bight. But right now, if you look at sea otter numbers, they're not expanding. Something is stopping them from growing to a larger number than they are. And if you think about those numbers I was telling you about earlier, 100,000 otters were taken over a couple of decades from the California coast. We have less than 2,000 otters now, and they're not increasing. And so that may signal that there's some other ecological problem that's facing otters along the Big Sur coast. So unfortunately, maybe it's not a problem, because without the population expanding, there may not be that much of a push to send them down south. You guys? Yeah, way in the back.
What can you say about the kelp forests down here in Southern California? It seems like they don't stand much of a chance.
Because? Are
they doing better? Are they dying off due to water changes, water quality?
The kelp forests down here, I haven't been following the way I've been following the ones up in Monterey. The kelp forests here cycle, but they're also affected by water quality. They're affected by a different set of interactions too. It's not just otters down here that were controlling sea urchins. There were lobsters as well. And so one of the things that happens with marine protected areas is if you preserve a little bit of coast and lobster abundances go up, then that can change the number of sea urchins, and that can change the health of the kelp forest. Any place like this with so many people and so much activity, recreation on the water, recreational fishing, commercial fishing, shipping, you're going to have some environmental problems. And I don't think the world is going to ever work with us saying we're going to leave the natural environment completely alone. I think you've got to figure out what parts of the natural environment you want to keep as good as possible and what parts you want to turn into a big international shipping port. So that's not a very good answer to your question. The kelp forests here cycle, as far as I know. The main issues with them is not just the forest, but the rest of the ecosystem as well. And as we eat that ecosystem and stress it out in so many other ways, then that forest itself is in danger.
Do you want to take one more question?
I'll take one more question. Yes.
How sustainable would you say Monterey Bay is right now?
That's the simplest question, and it's really the hardest one, isn't it? Right now, I'd say it's pretty sustainable because of this confluence of different points of view. It's not perfect by any means. I mean, the number of whales is not right, the number of otters is not right, there's invasive species and things like that. But it's in better shape now than it has been for the last 2 centuries. So it's in much better shape. What's going to happen over the next century because of global climate change is something that I don't think that we can really predict, and that's a big worry. All the gains that we may have gotten up till now may be lost because of that. How we're going to deal with it is, I think, one of the main issues for the future. It's the issue that your generation is going to have to face. Hopefully, you're growing up in an environment where global climate change is not something you have to suddenly learn about, but it's intrinsic to your education, and that when you get the power to deal with it, you'll know how to deal with it. That's my hope, and I wish you the greatest luck in the world.